All right. Today we get into finding slope from a table. Okay. So to find slope from a table, we want to determine the constant rate of change. Or slope for x and y. The constant rate of change and slope are actually the same thing. All right. So you find the constant rate of change for real world problems. And the slope for algebra problems. And slope is written as y over x. Remember, we always say the change in y over the change in x?
Yes.
And we write it as a unit rate. Remember, a unit rate has a denominator of 1. Okay. So again, we're looking for the change in x and y. So like in that first example you see, if I lower this just a little bit, you can see the y column, the total cost of balloons are going up by 6s. The number of balloons are going up by 2s. So again, change in y over the change in x. There's your y, there's your x. And again, 6 over 2 converts to 3 over 1, which then should just simplify to 3. All right, so if we do number 2, look at the change in x. What do you see as the change in x? Yeah, it's going up by 2 every single time. 2, 2, 2. What about the change in y? Julian, what about the change in y, since you're so busy talking, seem to know the answer? You don't know. Javon.
Total Earth.
What's the change in y?
It's 17.
Not 50, 17. Right? 50 and 50, when you subtract, so this is 17. So our change is going to be 17 over 2. Okay? We try to stay away from writing it as a decimal, right? Because if you write it as a unit rate, technically that's 8.5 over 1, which is 8.5. But again, you want to be careful with rise over run. All right. Everyone got that? All right, so let's talk about number 3. Notice number 3, it's not the same rate of change, right? Look at my x's. From 2 to 4 is what? 2. What about from 4 to 8? And then from 8 to 10? Okay, good. Well, what about my y's?
8.
From 1 to 2 is 1. From 2 to 4? And from, what is it, 4 to 5? So look at change in y over the change in x. That's 1 over 2, right? The next one is 2 over 4, which is still 1 half, right? And then 1 over 2. So our slope here is a half. Because 2/4 can convert to 1 half. So even though they go by different intervals, the change is still the same. And that's the important part. All right. What about number 4? Is x increasing or decreasing?
Decreasing.
Yeah, negative 2, 0, 2, 4. So what's it increasing by? 2's, right? All right. What are y's increasing by, Julian?
8 or -8.
Right, they're not increasing, they're decreasing by 8, right? So they're increasing by negative 8 every time. Minus 8, minus 8, minus 8. Well, minus 8 over 2 is what? Yeah, negative 4 over 1, which is negative 4. All right, so I'm going to pause right now. I'm going to let you guys, with your partner, and Julian, you can just slide down and work together. Let's try 5 and 6 in the back real quick. All right, so we're going to pause this video. You can try 5 and 6. All right. So what'd you get for the first one? Number 5, 1/5.
Yeah.
All right. Well, again, you're changing. Your x's are 10, and then your changing y's are 2. So 2/10 is 1/5. Very good. So you got it. No, 2/10 is not 5. 10 halves is 5. Because remember, you're going to divide 2 to the top and 2 to the bottom. All right, so what'd you get for number 6? 9?
Yeah.
All right, so we're going up by 2's here.
And then 18.
And 18 here.
18 over 2 equals.
So 18 over 2 is 9 over 1, which is 9. All right. All right, our last little bit here. You're going to find a slope for each table. Determine if the table represents a linear relationship. Circle yes or no. And remember, linear must have a constant rate of change or slope. So again, with your shoulder partner, I want you to attempt these 4. Okay, if you can find it, let me know what the slope is and if it's linear or not, yes or no. All right, and then we'll see how you did with those 4. So 7, 8, 9, and 10, we're going to give you about 5 minutes. Easy, right? Were the first 2 linear? Yeah, they were. Again, we'll show you why here. But the first one was linear because this is increasing by 3, by 2, and by 3. And this is going up by 21, 24, 21. Well, 21 over 3 is 7, right? 24, I'm sorry, that's 14, not 24. 14 over 2 is 7, and 21 over 3 is 7. So your slope is 7 here, right? And then in number 8, this is going up by 8. That's going up by 6. And that's going up by 10. And this is going down, right? This is decreasing. So by 40, by 30, and by 50. So negative 40 over 8 is negative 5. Negative 30 over 6 is negative 5. And negative 50 over 10 is. So our slope here is negative 5. Now, down here at number 9, okay, when x is going up, this is going up by 3, right? 2 and 4. Well, over here, this is going up by what? 72?
42. 102.
So 72 over 3 is 24. 42 over 2 is 21. And 102 over 2, or 4, is 25 and a half. So none of these are the same. So this is not linear. And basically the slope, there's none. There's no slope. Because there's no constant rate of change. None of these are constant. All 3 of them, all 3 changes are different numbers. So there's no constant rate of change. Okay? So in number 10, from negative 6 to negative 3 is 3. That's 6. And 3. And then over here, it's decreasing, right? I'm going down 6, 12, and 4. So negative 6 over 3 is negative 2. But when I do negative 12 over 6, negative 2. So far, so good, right? Oh, no, this is, yeah. But look at this. Negative 4 over 3 is what? So is that a constant rate of change? No, because this number screws it all up. So there's no slope, and it's not linear. Because, again, no constant rate of change. Okay? So I'm going to